Yes, so good afternoon or good morning, wherever you are in the world, to this panel event webinar on visualizing and analysing grid data by Synaptec. Firstly, a very warm welcome to everyone who's joined us today. Thank you for your time, it's much appreciated. This is the fifth in a series of webinars and events we've performed in 2021, with a few more to come. So as with these events, I'd like to take just a few minutes to allow latecomers to arrive on the webinar. So in the meantime, I'll do some housekeeping if that's okay with everyone. So if you'll notice, the Audible, the microphone and the chat facility on Zoom has been disabled for the purposes of this particular event. That is just to allow us to move through the questions and answers. The important thing is to realise that the question and answer button is going to be active throughout all. We certainly encourage you very much to make active use of that button and ask us as many questions to challenge both the panel and the experts who are at the side here to handle any questions you may have on the content. So in the meantime, any questions and answers that we can't manage during the course of the event will be recorded, and we will get back to you with them in a few days afterwards, as well as the recording of this particular event today. So we will be able to make sure that anyone who misses it will be able to see it in the not too distant future. So this, as I mentioned, is one in a series of events we've done in early 2021. Where just for your knowledge and attention, we intend to have a second series of events that we are currently scheduling for the second half of this year as well. So please keep an eye on our website, look out for further events that may be happening in the not too distant future. So without any further delay, I'd like to welcome and introduce our panelists today. We have Stephen Blair, who is our Head of Power Systems here at Synaptec. And we have Sean Murphy, who is the CEO of PingThings Incorporated. The panelists will take around 10 to 15 minutes to go through a discussion and some slides to just prompt a further discussion on this particular subject. So we'll bear with you with that. And please remember, the webinar will be left open for a couple of minutes at the end of the event, just to allow the last round of questions and answers to be captured. So without any further ado, I'd like to hand over to our first panelist speaker of today, who is Stephen Blair. Carry on, Stephen.
That's great. Thanks very much, John. So how I thought I would kick things off today is something a bit unusual. So this topic of this panel discussion is about visualizations and analytics for the power grid, which I hope that's what the audience is expecting. But this is something a bit left field, but I think it's quite a very good example of an elegant and informative visualization of time series data, and bringing in some other dimensions. So what we're actually looking at here is a quite old diagram from about 150 years ago of which depicts Napoleon's march into Russia and the consequences that happened from that. And you can see it starts off with the kind of brown sort of tan color on the left-hand side, and the width of that tan colored area represents the size of the army. So it starts off with over 400,000, an army of over 400,000 soldiers, and then as they march gradually towards Moscow, they suffer various fates, such as illness and of course the opposition preventing their march forward. And then eventually they get to Moscow, but then they retreat, and that's what's shown by the black bar, which shows their path and their ever dwindling numbers as well. And you can see eventually when they get back to the starting point, their numbers are reduced to about 10,000. So it's a disastrous excursion into Russia. What's also interesting is that you can see along the bottom there's some temperatures that are annotated for the return journey, and you can see they suffered through a really bitter winter during that retreat, which is unfortunate timing. And there's some other events going on that are highlighted here. where there was a sort of flanking maneuver as well that happened, and then that rejoined the main retreating army. And also there was a bit of a disaster crossing a river. You could see sort of in the middle as well, where about half of the people just died at that stage. So this diagram manages to bring together, 5 or 6 different dimensions of data very, very cleverly into one single diagram that's quite elegant and without being, it's quite nice to look at. And I think it tells you, as well as telling you all the little details along the journey, it also sums up quite succinctly the main, the main overall idea here, which, I've seen this picture annotated with simply the phrase, the cost of war. So this really tells you a story about how devastating these engagements could be, particularly back at the time when it happened. So the point of this really is just to show you this is the sort of excellence and thought that I think we need to bring into the power industry, which is generally much safer, but that does deserve this sort of same attention to detail and craft in how we look at data. So I think I've spoken for enough there. I think what we like to do is we've got about three different poll questions, and we'd like to invite the audience to participate at this point. And so now we're not talking about Napoleon and history. Now we're back to power systems. And what I'd like for the audience to vote on is what you think are some of the main issues that the industry faces right now, that need to be resolved so that we can get to the point where the industry can benefit from useful information presented correctly that allows operators or other people in the industry to make good decisions or better decisions or faster decisions or that sort of thing, or save money or whatever it is. So I think John has put the poll up for everyone to vote on. So please make any decisions, and I think you should be able to pick multiple if you like, and we'll have a look and see the results. So the results so far are looking like the first option, the availability of data, is definitely in the lead. Yeah.
We'll just give that a few more minutes for the latecomers to just add on there. You can see how things are changing. And if we look at the results on that first poll, very interesting, not necessarily surprising, but availability of data being by some considerable margin the most popular.
Yep, that's interesting. Yeah, so thank you everybody for your participation there. Yeah, I think availability of data definitely sounds about right, but I think there's other aspects that other people have voted on as well, like the infrastructure, the communications to actually deliver data, get it from potentially remote locations to wherever it's needed. I know for myself from doing work with like power quality meters, it can be very difficult to process the data, particularly when it's not networked, it's not synchronized, and getting the people on board to who are able to work with the data comfortably and do interesting things with it. I think the industry needs more of those people. Those are really critical. I've been speaking a lot. Sean, do you have any comments? Anything you wanted to add at this point?
Actually, I'll jump in briefly, and I think it's very interesting. Availability of data could mean so many things, right? It could mean, like, was any data collected? Did the sensors actually make measurements? Are there sensors in the first place? Can I access that sensor data because it's in a particular silo, because it's sold by one company and they offer one software to access and use that data? Or it could mean that I just have so much data that accessing it takes a really long time. So the availability is limited by your ability to actually interact and engage with that data. So it seems like availability is a multifaceted, multidimensional issue. But it's great to see that, clarity, and that's 90% of folks here think that's the most important issue.
Yeah. Yeah, thanks, Sean. That's a good point. There's quite a lot of subtleties behind that.
And I see there's a question in here that's come in that may be of interest, Stephen. Someone is asking why do you think it's important to synchronize the measurement data?
Yeah, my answer to that would be, and Sean probably has some good points of view as well. My answer would be is just to really make sense of the data and to make meaningful decisions from it. It's essential that it's time synchronized, because then you're not really necessarily comparing like for like if you can't depend on knowing when the data was measured. From previous work that I've done, we had to throw away a lot of data because we were just uncertain about when it was measured, and we had to exclude it from the analysis, and that meant our population size for the data that we were analyzing was a lot less. And also it gives you more data ultimately to use, and it saves time as well, because you don't have to pre-process it to check that it's synchronized.
So we have another question here from Ash Gupta, whose question is: we can deliver PQ data in real time in granular detail. The issue is that customer side, there is not people bandwidth to track and respond to alerts and data. How would you overcome this?
Yeah, so I can start to answer that, and I think Sean will have stuff to say as well. But yeah, I think that's a key issue, is having the person bandwidth to deal with it is definitely an issue. And I know utilities are already very busy, very smart people at utilities doing lots of useful things, but dealing with new technologies is hard. And I think really the answer is that we need support from like R&D to develop techniques, and we need these techniques to be able to be automatic, so that they can be sort of more generically applied, and so they don't require a human operator to click through buttons or to do bespoke work for each case. I think it needs to be as automatic as possible. Any other thoughts on that, Sean?
Yeah, so I think you're highlighting a critical issue, and it's interesting because I've seen this not just on the utility side. Years ago, helped build out a large-scale biosurveillance system that tracked disease outbreaks right after 9/11. And if you reported too many events, too many anomalies in all of the data streams to the medical staff, they just ignored you because you tried wolf all of the time. And I think the combination is, first of all, and it connects directly to this session, intelligent, well thought out, fast data visualization, so that you are presenting the customer with just the data that they need in as interpretable form as possible. And then I think on the other side, and Stephen was talking a little bit about this, everyone talks about machine learning and AI, oh, they're going to change everything. I think what we're going to see are those types of algorithmic approaches to helping manage and down select and focus attention. Like the human attention is the valuable commodity, and we're going to use those algorithms to down select and focus that attention on what we believe matters most.
Yeah, very interesting. Good.
Yeah, thanks, Sean.
Yeah, thank you, Sean.
So
shall we move on?
Yeah, so there's not going to be a lot of slides here, but I just wanted to highlight some examples that I think are good examples of some power system visualizations. There are unfortunately quite a lot of bad examples, but I'm not going to embarrass anyone or anyone's work here. But this is something that some colleagues of mine at Strathclyde University in Glasgow, they've been looking at this general topic of wide area system frequency response and related areas quite extensively, and this is an example graphic of a real event that happened in the UK some years ago, and I think in this case it was the interconnector between England and France which tripped, which is typically quite a common occurrence, particularly with the older technologies used in the older interconnector. But what's nice here is you can see, as the event's happening, you can see what's happening in the frequency over a large geographical area, and also the second map has the rate of change of frequency behavior. So these are, when you look at the plot on the left, you can see something crazy is going on, but it's only when you see it geographically you can pinpoint, oh, okay, I can see exactly where that's happening, where's the epicenter of this event. So this is quite a nice way of bringing together multiple dimensions in a way that's just quite nice to look at as well. Here's another example and this is from NCEPU, which is university sort of northwest of Beijing. Some of the work that they've been doing, I visited them a few years ago, and they were just starting to look at some, deploying lots of PMUs to look at oscillations from large wind farms. And I think where they've developed this work to recently is being able to characterize short-term transient events in the grid and display them as a sort of spectrogram. And you can see visually that each of these 4 events that they've picked out have a slightly different characteristic. A human can look at those and work out what's going on. And then, of course, there's established kind of image processing techniques to allow a machine, so some sort of algorithm, to do that automatically. And I think this is quite a nice way of looking at these types of events in a novel way, and it leads on to more automated analysis later on. So something that Synaptec's doing is, this isn't really analytics or machine learning. It's a bit simpler than that, but we're monitoring lots of locations simultaneously with time synchronization, as we talked about earlier, in order to pick up on abnormal events. So for example, when one location starts doing something weird, starts doing something that the other locations are not doing, in this case, it's a very subtle increase in current, which might indicate degradation of the health of a component, we can pick that up immediately and display that deviation and record it, and record all the context of all the other measurements are doing at the same time, so that someone can always come back and look at that report and look at all of the context and see what happened. So next, I'm going to stop with the slides and throw another question at the audience. Just to keep everyone on their toes. So this question is about what are the priority areas for delivering insights from data. So what do power system operators and other stakeholders need from data? So I've got some suggestions here. Again, you can pick many of these if you want, but we'd be interested to see what kind of filters out as the kind of the most popular choices. So I've got things like finding faults and working out where they happened. Maybe so you can send a crew there a bit quicker, or you can plan how to deal with it a bit better. Oscillation issues are becoming increasingly important in the grid, and dealing with these automatically would be desirable. Renewables, of course, bring lots of essential benefits, but the inverter connected or converter based generation adds a lot of side effects that have to be addressed. Anything else operationally in the control room, that's important. Asset condition monitoring is another factor that I think is also important. And then the last one is just any other utility day-to-day operations. So thank you all for voting. We've got quite a spread of results here.
Quite interesting, yes.
And again, the first one, fault detection and location, has come out the top. These suggestions are probably a bit vague to really nail down exactly what was meant. They're kind of a bit open-ended. But yeah, it's interesting that almost everything got some votes. The last one didn't get any votes, maybe because I hadn't explained it by the time I got there. But
okay, that's very interesting. Do you have any comment on that, Sean?
I think this tracks reasonably well with what we've seen in North America, in that there isn't a singular killer app for that utilities want tackled, but it's a diverse collection of capabilities.
That makes sense. Yes.
Yep. Yeah.
Good. Excellent.
Okay. So.
Okay. Moving on.
I'm going to stop, and I think Sean is going to share the next part. So it's over to you, Sean.
Excellent. I'm pulling up my slides. Here we go. Okay. You can see that, right?
Yeah, can see that fine, Sean.
Excellent. Excellent. Okay, so I have a couple minutes. I want to talk to you about my perspective, PingThings perspective on data visualization for the grid. And really, we kind of approach this from a very biased, but a unique perspective. We sell a data time series platform for data management, analytics, and AI. So we are coming at this problem from a very particular space, and we're looking at this at scale. So when you have just an overwhelming amount of data, time series data. So you got a lot of sources of time series data, lots of different types of sensors are generating time series at different frequencies with differing amounts of time alignment. And when you look at a utility, today's utility is, even if it's just SCADA, tends to be generating terabytes of data per year, if not hundreds of terabytes per year if you're focused on synchro phasers. And with point-on-wave, we see the potential for utilities to generate petabytes of data per year of time series data. And this obviously is a lot of data, far more than a single hard drive could handle. And the problem's only going to get worse, because as more and better broadband becomes available, more time series data is going to get generated. It's like if you add a lane to a highway, you're going to get more traffic. And we know this is coming, if not in many cases already here. And making this a little bit more complex is that oftentimes if you buy a sensor from one manufacturer, the data only goes into their software. So you have these data silos. Now, our mentality and philosophy is that if we can drop the cost of working with data, the cost of experimenting with it, the cost of really understanding time series data from your sensors, then what happens is we'll see an explosion in not just, there won't just be 5 use cases for this data, but there will be dozens. And really a key part, the first step in experimentation is visualization. It's absolutely essential because use cases and analytics have to come from somewhere. And typically those ideas arise when engineers and other folks are working with the data, actually seeing the data. So visualization is essential. And what happens is when you have a little bit of data you can fit it on a single computer, but with a large a grid system, distribution, transmission, or generation, the amount of data, the amount of time series data generated quickly swamps what a single computer can handle. It only keeps growing. And what we see due to technology limitations is that most folks are looking at the last 10 seconds or the last 10 minutes. And this is where all the use cases, this is where people's heads are at. And in reality, like all of that data is important, but we can't visualize it, we can't interact with it, and we can't really do what we want to do with it. And so, and this is kind of at the crux of data interactivity paradigm laid out by Schneiderman about 25 years ago, that when you're working with one of these large data sets, first you overview, and then you zoom and you filter, and then you get the details on demand as you need them. And I think Google Maps offers a really great firsthand example of this, because let's say you fly into a new city, you want to find coffee, you start with the high level view of the city, and then you zoom in to the block where you think the coffee shop is, you select the coffee shop, and then you get the details that you want. And you repeat this process as you explore and start to understand the city that you are in, which is defined by this geospatial data. And interacting with time series data at scale is very similar. Overview first, zoom filter, and then you get details on demand. So what we've tried to do is to make this as fast as possible, as interactive as possible with petabytes of time series. Here is a user in our web application that's sort of filtering, and then, oh, wait, there's the data. That is literally years of PMU data that just loads. And now all of a sudden, oh, there's something interesting. We need to zoom in. And the engineer needs to zoom in. Now we're zooming. We've gone from years to a day down to minutes. And now, oh, wait, here's an interesting event. My DFR triggered. There's my continuous point on wave data. Boom. That's pretty interesting. And that starts the creative juices flowing to start realizing new use cases. Just to jump ahead a little bit to conserve some time, we also tried to do this from a geospatial perspective, where we want to enable this type of exploration of time series that's flowing from real world physical assets that, again, it's very quick and it's very easy and it's very intuitive. Because this is where inception happens for new ideas. Mm. Now, I'm not going to show this video. We're doing real-time signature identification in multiple 10 kilohertz streams. It's not as sexy as the previous video, and I don't want to take up too much time. But the bigger picture is that with fast data and viz, it creates these opportunities that you can't see from where you're standing. So, and I love the map analogy because we've all dealt with it. When you have small data and flow tools, what happens is it imprisons you in all of these assumptions that are often invisible. It's like when you had to do a road trip 20 years ago, you got out your map and you played around and you tried to figure out where you were going and which routes to take. And now on your smartphone, you can literally speak the address. Google makes literally petabytes of information, geospatial information available that routes you. And when you think about it, if you could do instantaneous real-time mapping, like navigation's the first obvious application, right? It's the first use case or one of them. But what happens is once automatic free navigation becomes just the standard, then all of a sudden there are all of these other applications that become possible that are built on top of this capability that has now become an assumption. And we see the same transition. It's starting in utilities. With very fast access and fast data, great visualization, then what happens is you start using the data more, it becomes assumed you can interact with that data. And then this new wave of use cases can explode, a Cambrian explosion of use cases, if you will. And that's why we're really excited. The first step is visualization. And I will stop there.
Okay, thank you very much, Sean. I've got a question on that. From the customer's perspective, is how are they reacting to this new ability to see data at such a minuscule level that they can react upon and move upon it that they just didn't have before? Do they have the infrastructure, the inside their business to actually use this data at the moment, or are we looking a little bit to the future on that?
No, the amazing thing is if you strip away, it's like handing someone a smartphone, like an iPhone for the first time, and they're, oh my gosh, mind's blown. All of these constraints that existed are gone. And then the two big things that we see almost every time is that the first one is, oh my gosh, I can't believe how much is going on my system that I had no idea was happening. This explains so many things. And then kind of the second thing that happens is when you have a much faster tool, then you start abandoning your old tools and just start using the faster tool. And then you start going down this process of automating some of these more mundane tasks so that you can engage meaningfully with more data. Kind of going back to Ash's point, Ash's question before. It really is, it's amazing to watch this transformation happen.
Yeah, very exciting. I think we're seeing a similar trend on the continuous point and wave side, are we not, Stephen? As we introduce customers to this, they think, oh, wow, this is a lot of data.
Yeah, we're seeing a lot of interest from customers who, they've heard the phrase continuous point and wave, and they understand the promise of what it can deliver, but they don't really know where to start. I've also seen some of Sean's customers, PingThings customers, present on what they've been doing and some of the things they're able to uncover so that they never would have known about before. I think one example was Dominion Energy presented on how they found some interharmonics that was being injected into their grid, into their system. And they had no idea it was there, and it's just sort of an emergent behavior that I think was due to the interaction of multiple inverters feeding into their network. It was only through having this wide area data collection and the ability to visualize it and see what's going on that they found it, and they could then take steps to maybe mitigate it.
Yep, fantastic.
Okay, so this is really the last slide, and this sort of kind of links to what Sean presented about how things are sort of ramping up. And this is a completely non-scientific slide, by the way. It's just a gut feeling sort of slide. And here I'm just trying to show, here's some of how the grid is changing quite fundamentally. And I've just labeled it wind and PV, but that includes a whole lot of other stuff as well. All types of renewables, inverter connection, the impact on system inertia, how frequency control and protection might be impacted by that, and that's ramping up quite significantly just now. And we could easily argue about the steepness of these curves and the shape of the curves, and it'll be different in different countries, but that's a rough estimate of how that's progressing. And then there's another aspect related, which is electrification of heat and transport. So that includes electric vehicles, heat pumps, and everything else. And I think that's a bit slower. The take up of that is a bit slower, but it's coming, and it's already started for sure. And along with that, link back to Sean's presentation. There's the rise of PMUs, which have been around for several decades, and there was a significant increase of that in the past maybe 1 decade globally. And more recently, we're seeing continuous point and wave, which has always existed. It's just not being networked, and it's not being kind of looked at over a wide area in a synchronous way. And it's only recently that that's become possible. So this plot is really just kind of to show how these things kind of interact. Of course, there's no real axis here. There's no measurements, but this is just it's meant to be provocative to showing you how these technologies kind of come together. And I think there's a lot of value in continuous point and wave, and that can be harnessed to help a lot of applications. And that's kind of Synaptec is providing sort of the base technologies for that, and as Sean demonstrated, PingThings is ready to do that today.
Excellent.
So I think really just to finish up, we've got one last question, just to make sure no one in the audience is sleeping. So this last question is about how do we make this real? How do we get utilities using more advanced analytics in their day-to-day business? And I've got some suggestions here, and it'd be good to see what the audience think. So there's some sort of communities that are out there already, like IEEE is quite formal, but there's NASB, which is also really focused on synchronized measurements. There's NI4AI, which initiative that Sean is leading out in the US. Maybe we need some open source, a go-to place where everyone puts their data and models and is available, and that's sort of related to NI4AI as well. Maybe we need a big, huge industrial scale, high voltage test bed where utilities can do all these things, and they don't have to worry about affecting customers or any experiments going wrong. But they can test these things at scale, not just the primary equipment, but all of the secondary equipment that needs, and computing infrastructure and comms infrastructure is needed to make that reliable. Maybe we need some of like Sean's customers who are really excited about trying these technologies and put in the effort to make it happen. And then there's standardization, of course, is the last one, which I think it is necessary, but can be very slow to happen. So thank you everyone again for voting, and we should be able to see the results.
Yeah, it's very interesting, that one. It's almost neck and neck of open source and standardization, which is I don't think that's surprising to you, Stephen.
I think it makes sense to see standardization high, because that allows all the different people involved, all the different vendors to work together more effectively. But it's surprising to see such high demand for that in this poll, because, as I said, standardization is a very slow process, and typically industry can work a lot faster and innovate a lot faster.
Yeah.
So it's interesting. There seems to be a lot of weight behind the idea of open source library or some sort of repository of data that can be shared as well.
Very interesting. Any thoughts from your good self there, Sean, on how this looks from your perspective?
Yeah, as a company that's really been focused on putting time series data to use at scale, and getting utilities to start getting excited about this, we've spent so much time thinking about how to do it. And I think the singular answer that we've arrived at is we need to demonstrate, look at the ROI, look at how your business can transform. And honestly, if you don't, someone else will do it in your place, right? This isn't an if it's going to happen, it's a matter of when. And so the race has started. And we're very excited by, we don't see a killer app, we see killer apps. We see a swarm of them. And then as utilities become more aware of that, then they start to move in that direction.
Yeah, thanks, Sean.
That sounds great. An interesting feedback from the audience here is Ofwat Innovation Hub is pushing data standardization across the 19 regulated UK water utilities. Do we see that elsewhere? Do we see that in the States, that there is a push from within the industry for standardization, Sean?
There's some for a particular sensor type. I think in the world of synchrophasers, there are reasonable standards for at least protocols for transmitting and receiving the data. That, to my knowledge, has not happened with point on wave yet. But we have mostly encountered point on wave as really, it's not continuous, it's just a digital fault recorder that triggers, captures a second of data, and then kind of spits out a ComTrade file. But they're absolutely, standardization is sort of the bedrock upon which all of these things will be built. Otherwise, all of the time and energy and resources will go into kind of futzing around with proprietary standards or proprietary formats from vendors. And that decreases the ROI that could be derived from the analytics applications that sit at the top of that pyramid of effort.
Super. Yeah, good answer. Thank you, Sean.
Yeah, I think it would be fair to say that the standardized protocol and measurement requirements for PMUs probably did play a big part in it, in PMUs kind of being relatively popular. I think if that wasn't in place, it would have been, silos of one particular proprietary approach. So that was an important part towards its success. Although it's now in the process of potentially being replaced by STTP, which is another, it's basically the successor IEEE protocol. I mean, related to the comment from the audience there, again, it's related to water utilities. No familiarity myself with what's going on with water utilities, but I think definitely probably there could be more of a push from Ofgem, which is the electricity regulator, towards standardization. I think, you know, for example, for the IEC 61850 standards, which are they're more contained typically within a substation. But you know, I think there's only one UK utility person who's a member of the UK contingent for that. So you know, that's the sort of area where maybe all the utilities club together and, you know, put in a small amount of money reasonably, and they pay for a professional, experienced engineer to really attend all of these things and get on top of it and disseminate it back into the utilities, as well as the other direction, get what the utilities need in the UK, for example, and make sure the standards are compatible with those needs.
Yeah.
But standards are hard and time consuming, but they're also, you know, very important.
Yeah, that makes sense. Do we have any other questions from the audience and that are still with us there? We have a couple that have been answered, but we're looking for a few more. Is there anything on anyone's mind that they wish to put in here to the panelists?
Yep, happy to answer anything.
Okay, well, just keeping an eye on the time there. We're getting to the end of our 45 minutes, and we'd like to thank everyone for their kind attention and their time. This is who we are. This is Stephen, myself, and Sean. Please, if there's any other questions, get them through to us. There'll be plenty of opportunity to do this afterwards. We will be certainly capturing anything that comes in and feeding it back out to the audience, as well as a recording of this particular event. Also bear in mind what I said earlier, that this is only one of a series of webinars and events that we're going to be having. So please keep an eye open on our website for anything coming out to that. And if you can, join us once again. So for today, thank you very much. I'd like to take this opportunity to thank both Stephen and also Sean for their time today. It was very informative and quite thought leading as well. I'm sure everyone thinks that. So from that respect, thank you everyone for attending. If there's anything else, please reach out to us. We're happy, we're here to assist and to answer any questions you may have on this particular subject. Early days for some of it, but it's becoming more standardized and more the norm. So if there's anything we can do, please reach out to us and we'd be happy to be in touch. So for today, thank you for your time. And the very best, and thank you, and bye-bye.
Thanks, everyone.